pedometer using ATTINY85. What are pedometers? In this modern world, people adapt to the modern technology for every need. A computer geek uses internet to learn things. A fitness freak uses smartwatches to keep track of their workout. As we know, the modern smartwatches are almost equal to a smartphone. These days, smartwatches come up with different apps, Bluetooth, Wi-Fi, GSM and many more facilities. Fitness trackers make use of inertial sensors like gyro, accelerometer to track the distance moved, push-ups done, miles run and many more. But how are these devices tracking the activities of a person non-invasively with a very high accuracy? The devices which count the number of steps walked are known as pedometers. How do they work? Most of the wearables which calculate the steps are worn on the hand. These wearables calculate the number of steps walked depending on the movement of the hand. When a person walks, his or her hand will follow an oscillatory motion as a simple pendulum. These wearables monitor for these oscillatory motion and calculate the number of steps walked. We can also detect the oscillatory motion of a person while walking using gyro. We need to calculate the gyro values when the hand is at extreme positions. When the hand completes one oscillation, then it is considered as one step. Depending on the steps walked, we can calculate the distance covered. By using the person weight, height and the steps walked, we can find the calories burnt as well. In the next session, we will build a pedometer on our own from scratch using ATTINY85 and also an OLED display to view the number of steps walked. Before building a pedometer, we need to develop the algorithm for counting the steps depending on the gyro values. For developing this algorithm, we need ATTINY85, gyroscope sensor, Bluetooth module for viewing the gyroscope values while walking to find the minimum and the maximum values made by the hand. DYI pedometer. This circuit is very much similar to the one used in the previous session. It is used to send the gyro values over the Bluetooth. Please make sure the connections are all made appropriately as per the guidelines given in the table, and also the visualization is presented for the connection diagram in front of you. We request you to follow the connections meticulously so that things work fine later. The Bluetooth terminal HC05 app, which is being used for visualizing the serial data, cannot be used for plotting the serial data. We have searched for a lot of free mobile apps for visualizing the serial data in the graphical form. But unfortunately, we could not find any mobile apps for plotting the serial data. So, we can plot the serial data using Serial Plotter in Arduino IDE. This is a very important tool for graphically visualizing the serial data. If you have two Bluetooth modules, then it is preferred to connect them in master-slave configuration and then open Serial Plotter in Arduino IDE for visualizing the serial data. But if you have a single Bluetooth module, then connect the Bluetooth to the laptop and open the serial plotter. You have been presented with the screenshot of the serial plotter being highlighted appropriately in front of you. Connecting HC05 to PC or laptop. For connecting the HC05 to your PC or laptop, switch on your PC or laptop Bluetooth and click Add Bluetooth device. This begins search for a new devices near it. Among the listed devices, click the name of the HC05 module you want to pair it with. And finally, you will have to enter the pin for connecting it to the PC or to the laptop. We have presented the screenshot for the same and you can follow the same in your machine. After the HC05 successfully pairs with the PC or laptop Bluetooth, open the device manager where you can see another two COM ports listed in the port section other than the Arduino Uno COM port, and we have highlighted the same as COM12 and COM13 in front of you for your easier understanding. In my case, the port numbers are COM12 and COM13 as we conveyed some time back. Also, among these two, only one is useful for sending and receiving data from HC05. After testing these two COM ports, we have found that only COM13 works fine for us. So, you should also test these two COM ports and find which one is going to be useful for you towards sending and receiving data. Let's code it. The code for visualizing the gyroscope data using the serial plotter is the same as discussed in the previous session. For the data to be plotted correctly by the serial plotter, print the 3 gyro values in the same line separated by a comma. And also do not print any text along with the values. The code is very simple and we request you to go through the same. Visualizing the gyro data. You can see that with the serial plotter, we are able to visualize the gyro data very nicely. And the serial plotter plots the incoming gyro data in real time. We have observed that by making an oscillation of hand which is made while walking, the gyro z values goes from -250 to +250. So, if we count the number of oscillations of gyro z values, then we can obtain the number of steps walked by the person. You can also see from the graph that gyro z values alone consistently change a lot when the person is walking. So, monitoring gyro z values will be sufficient for getting an above average accuracy in step count. But if you want even better accuracy, you can observe the pattern in gyro x and gyro y values and implement a similar extended algorithm to the one taught in the next session. Not in every case the gyro z values oscillates between -250 to +250. If a person oscillates his hand very slowly while walking, then the gyro z values could vary between -210 to +210. So, to cover for all the types of walking styles, we will have to monitor for the -200 to +200 oscillations of gyro z values. You can see in the pictorial representation presented in front as blue for gyro x, red for gyro y and green for gyro z. Let's summarize. In this session, you have learned what is a pedometer, what is it used for and how does it work. It makes use of a simple pendulum motion of a hand to determine the steps walked by the person. We have used an ATTINY85 along with MPU 6050 and Bluetooth module to plot the motion of the hand. You can also use Bluetooth of a laptop as an alternative instead of a dedicated master-slave configuration. For any real-time project, you need to find the change in physical parameters. Find the sensors which detects the change in these physical parameters. Gyro is the best example for detection of the hand movement. Visualize the data from these sensors. The visualized gyro data can be seen in our case using Arduino IDE serial plotter. Observe the change in the sensor values when there is a change in the physical parameters. Here, only the gyro z values change consistently when there was an oscillation in the hand. According to the change in sensor values, develop an algorithm for detection. An algorithm is developed in the next session. In this tutorial, we will observe the MPU 6050 pattern. Once you observe that, you can always devise an algorithm based on the observation. We are also going to use Arduino's serial plotter and we are going to understand each of this step by step. All these are very interesting and easy to do and we request you to follow the steps one after another. Initially, we have connected the ATTINY85 and Arduino Uno alone for uploading the code to ATTINY85. And this is a very simple connection and we request you to follow the connection guidelines that we have given you in the theoretical description. Once the connections are all made, go to examples, Arduino ISP and open this file. So you need to go to tools again, select appropriate board and port and then upload it. Once you upload it, you will see the status as uploading and once done uploading has come, you have uploaded the Arduino ISP. Now come back to the file where you have written the core content. Go to tools, select appropriate board that is ATTINY and you need to select the appropriate clock frequency and the processor and programmer should be Arduino as ISP. Upload it right now and this might take few seconds for the process to be complete. The connection is all about having MPU 6050 and HC05 getting connected to ATTINY85. This is all very simple and easy to do and we are using the Arduino Uno only for powering up the ATTINY85 and we have not used any other digital or analog ports of Arduino Uno. Having told this and having completed the connection, we can go ahead with the next step. We need to go to Bluetooth settings and we need to pair the equipment. If it is already listed, we could have easily paired it. Since the equipment is not already listed, we will have to search for it. We are going to search for the new device and we are going to add the Bluetooth device right now. It might search and it will display all the available devices in its vicinity, and we have got the Wiley_BT, which is our new device, to be paired. Once clicked, it will prompt us with the pin, and we are entering the pin here as 1234. And once connected, you are now gaining access through the connection that you have made. Now please make sure that you are checking the COM port which is newly added. We have got two COM ports added here, COM12 and COM13, as we have seen. Now you need to go to tools and see that we are having the appropriate working COM port selected, and previously we understood that it is COM13 which is fully functional. So we have to select COM13 and we need to run it. And please open the serial monitor for our quicker reference. Now once the serial monitor is opened, you will get the data through COM13, and this is nothing but the gyro data. We are going to move the setup a little bit here and there so that we get the correct data plotted, and we are validating it right now. Also make sure that your baud rate is 115200 without fail. It is back to rest and the data is stabilized as it was previously available. Now we will see what happens when the COM12 is selected. You get nothing because COM12 is not the one to be selected and it is not fully functional, as we already told you. Make sure you select the correct COM port. We'll get back to the COM13 and we are going to go with the serial plotter right now, which is very easy to visualize the content. The serial plotter is available right in front of you and it is plotting the XYZ data perfectly. Since the breadboard is not in movement, you can see that the data is kind of stable and the baud rate is to be selected as 115200 without fail. We need to now move it a little bit so that we can see the data movements as proper representation and visualization through the serial plotter. You could have seen that XYZ is presented as curves that's based on the movement of your gyroscope. Now we are replacing the Arduino Uno with the battery source, and this should also work fine for us to test it. Now we are selecting the appropriate COM port and we are taking the serial plotter. Instead of Arduino Uno, this time we have a battery, 9-volt battery, and it should still work fine. We are moving this setup here and there so that we get the data plotted for XYZ, and it is also proven functionally working fine. So the point is, Arduino Uno is used for powering up and it can be replaced by a 9-volt battery. Now we are going to visualize this as a wearable, and you can see that we have used a breadboard in the left hand with two rubber bands tagging it to the hand properly. Now we are going to move this hand here and there, simulating the motion, and it should be plotting the data appropriately, and we are going to do it right now. With this pattern of data, one can devise an algorithm which can be very helpful for the processing. You can see that the movement is simulated right now and the data is presented as a plot. And all these are real time, and this is very accurate and easy to visualize as well. It is coming through COM13 and the entire procedure has been explained to you very clearly in the previous steps. More the moment, the data would be fluctuating the more, and you could see the plotting in front of you as well. This can be used to understand what exactly is the pattern, and this would certainly help you in getting an algorithm framed.